Rubik's Cube is one of the most famous games out there. There are many sizes, many rare shapes, but the classic, the lifelong, the Rubik's Cube. It is a cube in which each face has 9 squares, 3 by 3, and you have to move the cube so that each face has all the sides of the same color. Did you know that this whole system is just pure math? Let's go check it out. There are many contests with Rubik's Cubes, of speed, of making them blindly, of making very large cubes. And the truth is that I was amazed, if there are even some videos of robots making Rubik's Cubes that you freak out. Of kittens solving the cube, I haven't seen, but surely there are also, and mathematics. There are a lot of math in the Rubik's Cube, some of them very sophisticated, and I'm going to show it to you in 3 pieces of information. First, how many different ways can the Rubik's Cube be put? Well, 43 quintillion forms. Let's go check it out. There are 8 pieces of corners, and each of them can be in the 8 places of corners that there are, and the ways of counting them are called permutations. Permutations of those corners. The number of permutations of 8 elements is 8 factorial, which is 8 times 7, by 6, by 5, by 4, by 3, by 2, and by 1. But each of these pieces can be oriented in 3 ways, so we have to multiply 3 8 times, that is, 3 times to the 8 possibilities for each permutation. There are also 12 edge pieces that can be placed, therefore, in 12 factorial ways, and each one can be oriented in 2 ways, that is, 2 raised to 12 for each permutation. But not all of those ways are worth it. Can you guess why? Effectively, we cannot tear off the pieces and glue them differently. So only a third of those shapes respect the initial corner structure. Only one medium respects the initial structure of edges, and of them only one medium respects the original relationship between them, so we have a total of 43 quintillions. But is that a lot or a little? Well, if we put the 43 quintillion cubes each in one of the possibilities, followed by one of the others, these that measure 5 centimeters and peak, would occupy hundreds of light years, an unimaginable distance. The second is God's number. Cube geeks call the God number the minimum number of moves that must be made to solve the cube, whatever the starting position. There have been many mathematical studies. The subject is exciting. It began in the 80s, when it was proved that with less than 53 movements any position could be solved. The thing progressed, and in 2010, after a lot of programming effort and many hours of computing donated by Google, the phenomena of the cube Rikiki, Kosiemba, Davidson and Dithridge, proved that the number of God is 20. No matter how you put the cube, 20 movements are enough to solve it. The difficult thing is to know how to do it. And of course, there are contests in which, given a position, you have to solve the cube in the fewest possible moves. These people have found like 12 million positions that they need. The 20 movements, which would be the most difficult of all. They seem like a lot, but remember that the number of possible positions of the cube, it's tremabundies, yes, tremabundies. What's going on? Mathematicians also know Latin. And the third thing that freaks me out is for anyone who wants to dig a little deeper. I assure you that it is not difficult and that it is amazing. Third fact, the Rubik's Cube can be studied using an abstract mathematical theory called group theory. To understand ourselves, a group is a set and an operation that we can do on it and that has to have certain properties, such as the associative property that we saw at school. Do you want an example? If we take the whole numbers as a set and the sum as an operation, we have a group, and there are a lot of them. Well, it turns out that if as a whole we take the possible movements that we can do with the cube, and as an operation the composition of movements, do one and then another. It turns out that we have a group structure, and that group structure serves to always solve a Rubik's Cube. Studying the mathematical properties of that group of motions. You have methods to solve the cube, okay. Maybe you already have your method and you don't need the group structure, but let me tell you something. That study allowed programming computers to solve the Rubik's Cube and find the number of God. So you know, if you're a Rubik's geek, it may be that math is better at you than you thought and you need to subscribe to Deriving. What are you waiting for? We have 43 quintillion videos. More or less.